Swayam Prabha. Digital India. Educated India.
Okay, good morning. Today we want to revisit the quantity competition model in the context of a sequential move game. Recall a couple of classes back, we looked at the quantity competition model in the context of the two firms simultaneously choosing what quantity they want to produce, right. So, there we had two firms, firms 1 and 2 producing identical products, homogeneous goods, and the nature of the game was such that both firm 1 and firm 2 simultaneously chose what quantities to produce. Today we want to revisit that model, but in the context of sequential moves, and that is where we get into the very famous Stackelberg model, right. So, the sequential move quantity game is called the Stackelberg model. Okay. If we step back to the Cournot model, notice that we had two firms 1 and 2, who were choosing the quantities Q1 and Q2, and the way we solved the Cournot model was firm 2, we were solving for the Cournot-Nash equilibrium, which is essentially a statement of mutually best responses. So, we were asking what is firm 1's best response to every possible choice of Q2 chosen by firm 2. Then we asked what is firm 2's best response for every possible Q1 chosen by firm 1. We had drawn the two best response functions and we figured out what the Nash equilibrium was. And if I quickly draw the best response functions, so we have Q1 and we have Q2. The best response function for firm 1 was this downward sloping line. So, this was the best response function for firm 1 as a function of firm 2, firm 2's output, and firm 2's best response function was something like this. So, this was firm 2's best response function as a function of Q1, and the point where the two best response functions intersected was the Cournot output Q1C and Q2C, and the Cournot choice of output chosen by both the firms have identical marginal cost, which is C. The Cournot output was A minus C by 3B, and the Cournot profits of the two firms were A minus C whole square by 9B. Okay. So, let us keep this in mind as we solve the sequential move game. Okay. So, today we want to talk about firm 1 and firm 2 moving sequentially. So, what I mean by that is that firm 1 is going to be the first mover, right. So, firm 1 chooses its output first, firm 2 observes the choice of output chosen by firm 1 and then it is going to choose a Q2. So, in terms of the Stackelberg model, firm 1 is the first mover, and chooses Q1 first. Firm 2 observes the output choice of firm 1. So, firm 2 observes Q1 and moves second and then chooses a Q2. Well, what makes the game sequential is not just the fact that firm 2 moves after the output chosen by firm 1 happens, which is true, right. So, firm 1 moves first and firm 2 observes Q1 and then chooses Q2. That in itself does not make it sequential, that is just a statement of the timing. What makes the game sequential is that firm 1 chooses the Q1, firm 2 observes Q1 and then chooses Q2, and then firm 1 knows that this is what is going to be the case, right. So, what makes the game sequential is not just the fact is not just that firm 2 moves firm 1. Firm 2 observes Q1 and then moves after firm 1. Rather, firm 1 knows that this will be the case. What we are interested in the Stackelberg model is, we want to ask the following question: is there any advantage in moving first or second? Is there any advantage in moving first or second? In other words, from a strategy perspective, does firm 1 benefit by moving first, which means does firm 1's profit increase, or does firm 2 benefit by moving second, which is does firm 2's profit increase? Now, the firm which moves first, the first mover, is also called the leader. The firm which moves second, which is firm 2, the second mover, is called the follower. So, sometimes we use the terms analogously. We will use the first mover, or we will simply call it the leader. In this case, it is firm 1, or we may simply use the word follower or second mover. In this case, it is firm 2. So, the way we will solve sequential move games is by using a technique called backward induction. So, we solve sequential move games using the technique of backward induction. This essentially means that we look forward, which is we look at the decisions of the second mover, which is firm 2, find out what firm 2 is going to do, then step back one stage, which is go back to stage 1 and ask what is the best choice of firm 1, which is Q1. So, before we do the before we solve the model, let us understand the model analytically. Okay. So, let us be very specific with the depiction of the game. So, stage 1, firm 1 chooses Q1. In stage 2, firm 2 chooses Q2. So, firm 1 chooses Q1, firm 2 observes it, and in stage 2, firm 2 is going to choose Q2. So, let us ask if you are going to solve firm 2's problem first, because we are using backward induction, we will solve firm 2's problem first, and then we will go back and solve firm 1's best choice of Q1. Okay. Notice we have already solved stage 2, which is firm 2's problem, when we solved the Cournot model, because in the Cournot model the profit of firm 2 was the price times the quantity that it chose minus the cost of firm 2, and the inverse demand function P is equal to A minus B times Q1 plus Q2, and the cost of firm 2 is simply C times Q2, where little c is the marginal cost. So, if I were to write down firm 2's profit function, firm 2's profit function essentially would be A minus B times Q1 plus Q2, which would be the price times the quantity minus the total cost, which is C times Q2. Right. So, this is A times Q2 minus B Q1 Q2 minus B Q2 square minus C Q2, and firm 2's best choice of output Q2 was based on finding out the derivative of the profit function with respect to Q2, which gives us A minus B times Q1 minus 2B Q2 minus C equals 0, which gives us Q2 as a function of Q1, which is equals to A minus C divided by 2B minus Q1 divided by 2. This is this is firm 2's best response function, right. And if I were to plot firm 2's best response function, if I were to plot firm 2's best response function, so when Q1 is 0, essentially firm 2 is the monopolist and produces A minus C by 2B. So, if Q1 is equal to 0, firm 2 is a monopolist and produces the monopoly output A minus C divided by 2B. So, this is A minus C divided by 2B, and then when firm 1 produces the comparative level of output, which is A minus C divided by B. So, in other words, the quantity is such that prices have come all the way down to marginal cost. In such a case, firm 2 decides not to produce at all. So, firm 2's best response function is this. So, if Q1 is A minus C by B, firm 2's best response is actually going to be 0. So, this is firm 2's best response function. And if I had separately simultaneously solved firm 1's profit function or rather the best response function, we would have gotten a reaction function for firm 1, which would be something like this, right. So, this would have been A minus C by 2B and this would have been A minus C by B. This would have been firm 1's best response function in the Cournot model. Okay. But we are not solving it simultaneously, we have solved firm 2's problem and then we know that this is the Cournot solution. Now, let us first ask, should firm 1 produce the Cournot output or should it produce less than the Cournot output or should it produce more than the Cournot output? Okay, so, the first thing that we want to ask is, should Q1, so let us call the Stackelberg output as Q1S, should it be greater than the Cournot output? Should it be equal to the Cournot output or should it be greater than or should it be less than the Cournot output? Okay, so, let us first think about this. Okay. Now, if you look at the best response functions, these best response functions are downward sloping. This is a statement which is essentially equivalent to a game of strategic substitutes, right. So, the fact that quantities chosen by the firms are strategic substitutes is equivalent to saying that the two reaction functions are downward sloping. Now, if firm 1 were to produce more than Q1C, so this is the Cournot output Q1C, if firm 1 were to produce more than the Cournot output, so if firm 1 produces more than the Cournot output, then because the best response functions are downward sloping, in particular because best response function for firm 2 is downward sloping, firm 2's output will reduce. Firm 2's output will reduce, which essentially means that prices will not fall by as much as it would have fallen had firm 2 also increased its output, right. So, implies price does not fall by as much as it would if Q2 had also increased. And we know that Q2 cannot increase because the best response function for firm 2 is downward sloping. So, if firm 1 were to increase its output, notice that firm 2, which is always going to choose its best response, it is always going to choose its Q2 from its best response function BR2, will find that it will now choose a lower quantity of output. This is good news for firm 1 as the price does not fall by as much. So, this tells us that firm 1's output in the Stackelberg model is going to be greater than its output in the Cournot model, right. So, the fact that firm 1 produces more leads firm 2 to produce less because its best response function is downward sloping. That prevents the price from falling by as much as it would have fallen had Q2 also increased, which is good news for firm 1. So, this is good for firm 1. Now, let us ask, how does firm 1's profit compare to its profit under the Cournot model? So, how does firm 1's profit compare to its profit in the Cournot model? Again, let us think about this. So, in other words, we are asking what can we say about what can we say. So, in other words, we are asking what can we say about the Cournot profit or the profit that firm 1 gets in the Stackelberg model versus the Cournot profit. Now, because firm 1 moves first, one choice that it had was to simply produce the Cournot level of output Q1C, right. So, firm 1 is moving first and it is free to choose a Q1. As part of its exercise, it could have chosen the quantity that it would have chosen had both the firms moved simultaneously. But the fact that Q1S is greater than Q1C tells us that firm 1 finds it more profitable to produce an output Q1S as opposed to producing Q1C. So, firm 1 could have chosen Q1C, could have chosen the Cournot level of output, but the fact that it chooses an output other than the Cournot output, that it chooses an output Q1S, we still have to compute what the Q1S is. The fact that it chooses an output Q1S which is different, more specifically which is greater than Q1C, right. So, different than the Cournot output, implies that its profit must have gone up. That is, the profit under the sequential move game for firm 1 is greater than the profit that it would get under the Cournot model. Analytically, we will confirm all of these statements, right. So, we will find that the output chosen by firm 1 is greater than the output that it chooses in the Cournot model. We will also find that the profit that firm 1 gets is under the Stackelberg model is greater than the profit that it would have gotten had the quantities been chosen simultaneously. So, where are we now? So, we have found that firm 1's output is going to be greater than the output under Cournot. We have also found that firm 1's profit is going to be greater than the profit that it gets under Cournot. Let us now ask, what about firm 2's profit? So, how does firm 2's profit compare to its profit under Cournot? That is, we are interested in comparing the profit that firm 2 gets under the Stackelberg model with the profit that it gets under Cournot. Now, this is not obvious. And in fact, we can't directly compare the profit of firm 2 under Stackelberg with the profit that it gets under the Cournot model. To answer this question, it may be useful to first figure out what can we say about the total output under Stackelberg model. So, let us first ask what happens to total output? What happens to total output, which is Q1S plus Q2S? What happens to total output? In other words, what can we say about this total output compared to that under the Cournot model, right. So, we want to compare. So, we want to compare the Q1S plus Q2S with the total output under the Cournot model, right, which we already know. So, the total output under the Cournot model is essentially the Q1S plus the Q1C plus the Q2C, right. So, this we already know, these are the Cournot outputs. Now, we want to ask what happens to the total output. Again, this is not very obvious. Again, not very obvious, but if we look at the graph, we can conclude that the total output under the Stackelberg model has actually increased. Why is that so? We already know that the output produced by firm 1 under the Stackelberg model is greater than that it produces under the Cournot model. This leads firm 2 to reduce its output. So, we know that firm 2's output is actually going to be smaller than the output under Cournot. So that is a state that follows from the fact that since Q1S is greater than since Q1S is greater than Q1C, it must mean that firm 2's choice of output in the Stackelberg model is lower than that under the Cournot model. So, let us first make a note of that. Since Q1S is greater than Q1C, and because the best response function for firm 2 is downward sloping, it must mean that the output produced by firm 2 under the Stackelberg model is less than the output that it produces under the Cournot model. Okay. So, this follows directly from the fact that the best response function is downward sloping, right. So, the best response function for firm 2 is downward sloping, Okay. Let us again look a little bit deeply into the best response function for firm 2. Now, if we look at the slope of this line of BR2, the best response function for firm 2, we will find that the decrease in Q2 is smaller than the increase in Q1, right. So, that follows from the fact that if we look at the best response function for firm 2, given that firm 1 is producing more under the Stackelberg model compared to the Cournot model, and the fact that the best response function is downward sloping implies that the output under the Stackelberg model is lower than that under the Cournot model. We also note, looking at the slope of the best response function for firm 2, that the decrease in Q2 is smaller than the increase in Q1, right. So, the decrease in Q2, so let us make a note of that. So, decrease in Q2 is smaller than the increase in Q1. The decrease in Q2 is smaller than the increase in Q1, which must imply that the total output under the Stackelberg model is greater than the output under the Cournot model, right. So, while it is not directly obvious that the total output has gone up, we can reason it out by looking at the best response function for firm 2, that the fact that Q1S is greater than Q1C leads the output for firm 2 to go down, but looking at the slope of the best response function for firm 2, we can conclude that the decrease in Q2 is smaller than the increase in Q1, which must mean that total output would have gone up. This essentially implies, so in other words, total output has gone up, which then implies that the price must have gone down, right. So, the total output has increased, so that must mean that the price has come down. Now, the price has come down and the output produced by firm 2 also has come down compared to the Cournot case, right. Further, Q2S is also lower than Q2C. This implies that the profit of firm 2 under the Stackelberg model is less than the profit under the Cournot model, right. So, firm 1, which is the first mover or the leader, by choosing Q1S, which is larger than the Q1C, finds that its profit that it earns under the Stackelberg model is larger than that it gets under the Cournot model. Firm 2, which is the follower, ends up producing less than what it would have produced had it moved simultaneously. the total output under the Stackelberg model has increased. So, that has reduced the price, which then implies that firm 2's profit has gone down. Okay. Let us now solve the model analytically. So, let us now solve the model analytically. Okay. So, one other statement which might be useful for us to note here is the fact that total output has gone up and price has gone down together imply that consumers are much better off in the Stackelberg model, right. So, consumer surplus has increased. Okay. So, let us also make a note of that. Okay. So, now we will solve the model analytically. So, we already know what the best response function for firm 2 is, right. So, we know the best response function for firm 2 is given by this particular equation, right. So, we write down the profit function for firm 2 and we can figure out what the best response function for firm 2 is. Okay. So, let us use a new page. So, the best response function for firm 2 Q2 as a function of Q1 is A minus C divided by 2B minus Q1 by 2. Now, firm 1 which is moving first is a rational player and knows that based on its choice of Q1, firm 2's choice of Q2 would be given by this particular relation. So, firm 1 is a rational player, and knows that firm 2 chooses Q2 based on its best response function, right. So, essentially now firm 1 is asking what is the best possible Q1 that I can choose. So, firm 1 will incorporate firm 2's best response function into its own objective function to solve for the optimal Q1. So, in other words, firm 1 which has moved first knows that based on that Q1 firm 2 would have chosen its Q2. So, essentially firm 2 can also figure out what firm 2's best response is, or rather firm 1 can figure out what firm 2's best response is. So, it takes that entire best response function for firm 2 as given and then asks what is the best Q1 that I can choose given that firm 2 is doing what it is doing. So, now let us look at firm 1's profit function. So, firm 1's profit is P times Q1 minus the cost which is CQ1. So, this essentially is A minus B times Q1 plus Q2, but now the Q2 firm 1 knows is going to be based on firm 2's best response function. So, times Q1 minus CQ1. So, essentially we are going to substitute for the best response function for firm 2 based on what we have computed here, right. So, let us do that. So, firm 2's so firm 1's profit now pi 1 is A minus, so we can include the C also together, take the Q1 outside, minus BQ1 minus B times Q2. Well, Q2 is A minus C divided by 2B minus Q1 by 2 times a Q1. Now, if I simplify this, so the B gets cancelled from this term. So, I have an A minus C and an A minus C over 2. So, that is going to give me an A minus C over 2, and then I have a minus BQ1 and then I have a plus BQ1 by 2, that is going to give me a minus BQ1 by 2 times a Q1, and firm 1 is going to choose the optimal Q1. So, the firm 1 is going to maximize this profit by choosing its output Q1. So, essentially we write down the first order condition for firm 1, which is A minus C by 2 minus BQ1 by 2 times 1 plus Q1 times minus BQ1 by 2 which is equal to 0. So, that gives us so that gives us so if I take the BQ1 together, so I will get a BQ1. So, the Q1S essentially is A minus C divided by 2B. So, this is the output that the firm 1 produces in the Stackelberg model, right. So, on the graph, so if I were to, let us graph this once more. So, if I have Q1 and if I have Q2, we have firm 2's best response function, which is A minus C divided by 2B. So, this is firm 2's best response function. And for completeness, we will just draw the Cournot outcome. So, what firm 1 is choosing is, firm 1 chooses an output which is A minus C, which is A minus C divided by 2B. Notice this is also the output which is chosen by a monopolist, right. So, if I had only one firm in the market, that firm would have chosen an output which is equal to A minus C by 2B. So, this is, so the Stackelberg output, so the Stackelberg output Q1S essentially is A minus C divided by 2B, which is also the monopoly output. And given that firm 1 is choosing this output, firm 2 is going to choose its output based on its best response function. So, this is the Stackelberg output. So, firm 2's output is going to be, so if I look at firm 2's best response function, I have A minus C divided by 2B minus Q1S divided by 2, which is A minus C divided by 2B divided by 2. So, I will have the output produced by firm 2 is A minus C divided by 4B. So, this is the output produced by firm B, and that output is here. So, firm 2's output A minus C divided by 4B is firm 2's Stackelberg output, and we know that the Cournot output is A minus C divided by 3B. So, firm 1, which is the leader, produces more than the Cournot output, which is A minus C divided by 3B, and firm 2, which is the follower, produces less than the Cournot output, which is A minus C divided by 3B, which are statements that we had earlier written as well. Okay. So, we also said that the total output is larger than the output under Cournot. So, Q1S plus Q2S essentially is A minus C divided by 2B plus A minus C over 4B, which is 3 times A minus C over 4B, and this output is greater than the output under the Cournot model, which is 2/3. So, the output under the Cournot model is A minus C over 3B plus A minus C over 3B, which is essentially 2A minus C over 3B, which essentially means that the output under the Stackelberg model is greater than the output under the Cournot model. So, finally, the price under the Stackelberg model is essentially A minus B times the total output produced. So, that is 3 times A minus C divided by 4B. Now, this simplifies to A plus 3C divided by 4. So, we can compute the profit of firm 1. The profit of firm 1 is the price, which is A plus 3C divided by 4 minus the marginal cost, which is C, times Q1S, which is A minus C divided by 2B, right. So, this is the profit of firm 1. So, we have this is A minus C whole square by 8B. Again, this is greater than the profit that firm 1 would get under Cournot competition, which is A minus C whole square by 9B. So, this is the profit that firm 1 gets under the Cournot model, and for completeness, the profit of firm 2 is again the price, which is A plus 3C over 4 minus the marginal cost times the output chosen by firm 2, which is A minus C divided by 4B, and this turns out to be A minus C whole square by 16B, and this is less than the profit that firm 2 gets under the Cournot model, right. So, all of these were statements that we had intuitively argued a little while earlier. Now, we are able to show rigorously that the output of firm 1, which is firm 1 produces a higher output, firm 2 produces a lower output compared to that under the Cournot model. The profit of firm 1 is larger than its profit in the Cournot model. The profit of firm 2 is smaller than the profit that it gets under the Cournot model. So, a central feature of the Stackelberg model is that because one firm moves first, it leads to different implications for the two firms, right. So, in the Cournot model, both the firms moved simultaneously and the outcomes were the same output chosen by the two firms and the same profits that they got. So, a central feature of the Stackelberg model is that because one firm which is firm 1 moves after the other, the outcome is different for the two firms. Now, the leader, which is firm 1, gets a larger market share and earns a larger profit than the follower. Right. But an interesting aspect of the disadvantaged outcome for firm 2 is that paradoxically firm 2 does worse than what it did under the Cournot model when it has more information now. Notice the timing of the moves. Firm 1 chooses Q1, firm 2 observes the Q1 and then chooses Q2. So, essentially in the Stackelberg model, firm 2 has more information. So, paradoxically firm 2 does worse when it has more information about firm 1's choice of Q1, because now it observes the Q1. In the Cournot model, both the firms were simultaneously choosing their output. So, in particular firm 2 did not observe what firm 1 was doing. In particular, firm 2 did not know what the Q1 was. Now, firm 2 moves after firm 1. So, firm 2 has seen what Q1 has been chosen by firm 1. Surprisingly, even with better information, firm 2's profit is now lower than what it would have gotten had it not observed the profit. Okay. So, and the reason for this is the following. In the Stackelberg model, right. So, in the Stackelberg model, right. So, in the Stackelberg model, by the time firm 2 moves, firm 1 is committed to producing Q1s, which is equal to A minus C upon 2B units, right. So, by the time it is firm 2's turn to make a move, firm 1 has already committed to producing the Stackelberg quantity of output. Now, in the Cournot model, A minus C upon 2B is not a best response to firm 2's choice of A minus C upon 4B, right. So, if I look at the Cournot model, if firm 2 were to choose A minus C divided by 4B, firm 1's best response is not A minus C by 2B. In fact, it is some output which is given here, that would be firm 1's best response, right. So, in the Cournot model, A minus C by 2B is not a best response to firm 2's choice of A minus C upon 4B. So, firm 2 would not anticipate that firm 1 would produce that quantity, would produce that output, right. So, in contrast in the Stackelberg model, so in contrast in the Stackelberg model, what are we doing? We are not simply deriving firm 1's best response taking firm 2's output Q2 as some number A minus C by 4B, right. So, in contrast in the Stackelberg model, we do not derive, right. So, or rather we do not derive firm 1's choice as a best response to Q2 equal to A minus C by 4B. This is not what we did, right. What we did in the Stackelberg model was we incorporated, so firm 1 incorporated the entire best response function of firm 2 into its objective function and then solved the constrained optimization problem, right. So, it is as if firm 1 is maximizing its profit subject to firm 2's output being on its best response function, right. So, in contrast in the Stackelberg model, we do not derive firm 1's choice as a best response to Q2. Instead we derive firm 1's choice as its profit maximizing output, choice, given that firm 2 is choosing its output, choosing its Q2 based on its best response function BR2, right. So, that is what we did. When we solved the Stackelberg model, we simply did not ask is A minus C by 2B a best response to A minus C upon 4B, that is not what we did. We incorporated firm 2's best response function into firm 1's objective function and then solved for firm 1's optimal choice. And it is this part, it is this fact that distinguishes the Stackelberg model from the Cournot model. And this is the reason why the output choices under the Stackelberg model and the Cournot model are different. So, to summarize, a big lesson that comes out from the Stackelberg model is that moving first can have its advantage, So, firm 1 which is the leader moves first, earns a larger profit, and therefore, and hence is an important aspect of strategic interaction, right. So, that is a main takeaway from the Stackelberg model, right. So, so firm 1 benefits from being the first mover, firm 1's profit is larger than the profit that firm 2 gets. So, when firms are choosing quantities and the moves are sequential, it is a firm may benefit from being the first mover. Okay. Now, let us move on and now let us look at sequential price competition. So, until now we looked at the Stackelberg model which was firms competing in quantities. Now, we want to look at sequential price competition. Now, it turns out that sequential price competition when firms are producing homogeneous goods and have identical marginal cost has an outcome which is identical to what we learnt in the Berthra model. So, if firms compete in price, if firms compete in price and the goods are homogeneous and the goods are identical, then the outcome of the Stackelberg model where firms are competing in prices is similar to the Berthra model of price competition. And notice that in the Berthra model of price competition, price is equal to marginal cost, where C is the marginal cost. This was the outcome under the Berthra model. So, let us see why this is going to happen, why this is going to be so. So, let us again say firm 1 is the leader, firm 1 is the leader. So, it moves first, chooses a P1, right. So, it chooses a P1, firm 2 observes the P1 and then sets P2, firm 2 observes P1 and then sets P2. So, firm 2 is the follower, right. So, firm 2 is the follower as before, right. So, the marginal cost of production is the same for both the firms. Consumers will buy the product. So, this is other features of the Berthra model are identical, which is that consumers will always buy the product from the firm which charges the lower price. Firms have no capacity constraints, that is, if one firm charges a lower price than the other firm, it gets the entire market demand and it has enough capacity to meet the entire market demand. And if both the firms set identical prices, they essentially split the market, right. So, consumers buy from the firm which charges a lower price, and we will assume that there are no capacity constraints. If both firms charge identical prices, then the firms split the market. Right. So, let us ask what the outcome of this sequential price competition model is going to give us, right. So, if in setting its price, in setting P1, firm 1 must anticipate firm 2's best response to its choice of price P1, right. And let us see what firm 1 anticipates. So, if firm 1 chooses a price between the marginal cost C and the monopoly price, right. So, let us say firm 1 is choosing a price between C and the monopoly price. Well, what is firm 2 going to do? Firm 2 has an incentive to undercut firm 1 and capture the entire market demand, right. So, whenever firm 1 sets a price between the marginal cost and let us say less than or equal to the monopoly price, firm 2 essentially undercuts firm 1 and steals the entire market. So, firm 2 is not going to get any market demand. So, firm 2's profit is going to be 0. So, firm 1 is not going to get any demand and firm 1's profit is going to be 0. Profit turns out to be equal to 0 in that case. On the other hand, if firm 1 sets a price which is lower than the marginal cost, right. So, firm 1 is pricing below marginal cost, then essentially firm 2 does not want to match or undercut firm 1's price. Firm 2 will not match or undercut firm 1's price. In fact, its best response would be to strictly charge a price which is larger than the price that firm 1 charges and not make any sales. But in that case, firm 1's profit is going to be negative, right. And finally, if firm 1 charges a price which is equal to marginal cost, well, firm 2's best response is to match it, right. So, both firms are going to split the market and the profit of each one of these firms is going to be equal to 0. So, this behavior of firm 2 which firm 1 is going to anticipate, puts firm 1 in a bind. Charging a price greater than the marginal cost implies that its profit is going to be equal to 0, right. So, it does not make any sales, right, nobody comes to it, its profit is going to be 0. Charging less than C is again not optimal because its profit is going to be negative, right. So, if it charges a price less than marginal cost, its profit is going to be 0. So, the best that firm 1 can do is to charge a price which is equal to marginal cost, and the best that firm and firm 2's best response is essentially to match it, right. So, the best that firm 1 can do is to set P1s equals to C, and firm 2's best response in stage 2 is to match it. That is, the price becomes equal to marginal cost, which is the outcome that we had under the Bertram model. So, same as in the Bertram model, right. So, now we have entirely different outcomes. So, when we looked at quantity competition, firm 1 moved first, chose a Q1, firm 2 followed, chose a Q2, firm 1 clearly benefited by moving first. When products are and even in that model products were homogeneous, were identical. In sequential price competition, when goods are identical, the outcome is same as in the Bertram model. So, there is not any benefit to a firm from moving first. Things change drastically when we introduce product differentiation and revisit the sequential price competition model. So, let us do that. So, we introduce product differentiation, and we have seen a model of product differentiation earlier in the context of the Hotelling's linear city model. So, we look at product differentiation and we look at sequential price competition. Right. So, this is a model that we earlier saw, wherein we had a line of unit length. Firm 1 was the first mover, chose to position itself, let us say, at one point, which is at the left extreme of the line. Firm 2 is the second mover, it observes the P1 and then chooses a P2, sets itself at the other extreme of the line, and in this model we had already solved for the demand functions for the two firms. Recall, right. So, recall the linear city model. So, if you go back and take a look at the Hotelling's linear city model that we solved, we had the demands of the two firms. We had the demands of the two firms as follows. So, we had the two firms essentially. So, we found out the indifferent customer, then we found out what all customers to the left of that indifferent customer go to firm 1, all those to the right of that indifferent customer would go to firm 2, and we had D1 of P1 P2 equals P2 minus P1 plus T divided times n upon 2T, where n were the total number of customers. The demand for firm 2 is P1 minus P2 plus T times n divided by 2T, right. So, firm 1 acts first. So, firm 1 sets P1 and then firm 2 sets P2 after observing P2, and the way we would solve it again is by backward induction. We look at what firm 2 is going to do, find out firm 2's best response function, which we already know because we have already solved for it under the Hotelling's linear city model. So, if you look at pi 2, we have P2 minus C times D2, which is P1 minus P2 plus T times n divided by 2T. So, if we find out firm 2's best response function and set it to equal 0, you could check, right. So, you can check based on what we did earlier that firm 2's best response function yields P2 as a function of P1, which is P1 plus T plus C divided by 2. The best response function was upward sloping. Now, firm 1 anticipates that firm 2 is going to choose its best possible, is going to choose its P2 based on its best response function. So, firm 1's profit is P1 minus C times D1, but now firm 1 notices that firm 2 is going to choose its price P2 based on its best response function minus P1 plus T times n divided by 2T. Now, if we incorporate firm 2's best response function into firm 1's objective function and simplify. So, in other words, if we substitute for P2 in here and simplify, we will find that firm 1's profit is given by P1 minus C times 3T plus C minus P1 times n divided by 2T. Now, to solve for firm 1's choice of best price P1, we take d pi 1 dp1 set it to equal 0, which essentially means that we have n divided by 2t. So, we have 3t plus c minus p1 times 1 plus p1 minus c times minus 1, which is equal to 0. So, essentially this gives us the Stackelberg price P1s as c plus 3t divided by 2, which is greater than c plus t, which is the price that we got under the case where the firms were simultaneous in the Bertrand model with product differentiation. If I substitute this P1s into firm 2's objective function, we will know that P2s turns out to be c plus 5t divided by 4. This is also greater than c plus t that we got under the Bertrand model with product differentiation. So, what we now find is both the firms charge a higher price. So, here prices are strategic complements, not just firm 1 charges a higher price than what it would have charged when it moved simultaneously, firm 2 also charges a higher price. Now, we can substitute these prices into the demand functions D1 and D2 into D1 and D2 and solve for the optimal quantities that the firms are producing, and then go back to the profit functions and figure out what are the profits of the two firms. If we were to do that, so we would find that firm 1 and firm 2 no longer share the market equally, right. So, if we substitute for prices and quantities, we will find that the profit of firm 1 turns out to be 9 upon 16 n times 2. So, this is just simple algebra, and the profit of firm 2 is going to be 25 over 32 n times t. These profits are larger than the profits that they would get under the Bertrand model when the two firms moved simultaneously. In particular, note that firm 2's profit is greater than firm 1's profit. So, here we have what is called a second mover advantage. So, unlike the case of quantity competition where firm 1 had the first mover advantage, here firm 2 moves second and has a second mover advantage because its profit is larger than the profit of firm 1. Thank you.